welcome to our channel. So today we are going to discuss about the effect of complex formation in solvent extraction. So before going into the topic, I will just elaborate some of the things like it's a topic from separation sciences module, and the topic is solvent extraction, and we're covering one of the numerical, that is the effect of complex formation in solvent extraction. So here is the question, and it's a detailed question, and we will split this into different parts and try to solve this question, solve this numerical. So first we have to understand the what's the question. A solution of iodine 0.1 gram in water 50 centimeter cube. So that's the initial concentration of iodine in water, and that's the volume of the water containing NaCl is extracted using 25 centimeter cube of chloroform, and that's the volume of the organic layer. And given that the G value, that's the distribution ratio for this system is 85, and to be noted that distribution ratio is basically the amount of the solute in organic layer divided by amount of the solute in aqueous layer. And then what we have to calculate is percentage extraction. There are two types: one when 25 centimeter cube of the volume is taken, and one when 8.3 centimeter cube of the volume is taken. So that's the volume of the organic layer. So first I will enlist how we can calculate the distribution ratio, or the how we can calculate the extraction efficiency. So there's a formula that's called CAQ. N is equal to CAQ into VAQ over DVORG plus VAQ. So that's the formula that is being used to calculate this power n, calculate the percentage efficiency of, like you have seen that in solvent extraction, if we do multiple extraction, then the extraction efficiency would be greater, and we will prove it. For the first time we have taken like 25 centimeter cube of organic solvent, and the second we have taken like 8.33 centimeter cube of the organic layer or organic solvent. So we will check like in which case the extraction efficiency would be greater. So coming towards this one, so this is basically the concentration in aqueous layer, that is after n concentrations. So we will enlist like CAQ. This is concentration in aqueous layer after n concentrations or n extractions. So that's the, like we have taken the solvent, we're going to extract that solvent. So like if it's a 1, then the n would be 1. So that shows the extraction or the concentration in the aqueous layer after n extraction, like 1 extraction. Then CAQ, this basically shows the initial concentration in aqueous layer. So in this case, the initial concentration is 0.1 gram. So we will enlist after that. I will just elaborate this formula, and after that we have to take like data from this numerical and solve it accordingly. Then VAQ, that's the volume of the aqueous layer, that is 50 centimeter cube. D is distribution ratio, and that is 85. So D would be 85 distribution ratio. Now I've already mentioned that distribution ratio is basically the amount of the solute that is present in organic layer divided by amount of the solute that is present in aqueous layer. So we will use this formula for two cases, like when we will use 25 centimeter cube, and the second case we will use 8.3 centimeter. For the first case n would be 1, for the second case n would be 3. So I will just use all these value in this numerical. So for the first case, for this CAQN, we have to calculate this one, and CAQ is equal to, that's the initial concentration, that is 0.1 gram Then comes water, that's the VAQ, that is 50 centimeter cube, uh, extracted using 25 centimeter, that's 25 centimeter for the first case we're solving. So VORG, that's the volume of organic layer, that is 25 centimeter cube. And the value is n because only one time they have used 25 centimeter cube at an instant. So n would be 1. There is like one extraction using 25 centimeter cube of the volume, and the d value is 85. So d would be 85. So when we place this value, c a q n equals, it would be like 0.1 into VAQ, that's 50 over 85 multiplied by this 25 plus 50, and whole power would be 1. And using the calculator, you have to use calculator, the value would become 0.0023 gram. So that's the volume after one extraction, the volume of iodine that is present in the aqueous layer after one concentration. So if we want to convert it into percentage, then there's a simple way. There's two ways. One of the simple ways, just multiply this with 1000, like that becomes 0.0023 multiplied by 1000, that would become 2.3, and subtract it from 100. So 100 minus 2.3, that would become 97.7. So the extraction efficiency would be 97.7% if we just take the one concentration of like 25 centimeter cube. So that's the first case. Then we're going to solve the second part in this case. So for the second part, like I will just mention case 2. For the second part, the VORG would be 8.33. Initially it was 25, so we have to use 8.33. Multiple extractions, so 8.33 centimeter cube. And everything else would be the same except for the value of the n. Like we are using the not 25 centimeter cube at an instant, but we divide it like 8.33 centimeter, then we are using 8.33, then we are using 8.33. So n value, number of extraction would be 3. So when we use the value, initial concentration would be the same, that is 0.1 into V equals, that's the same, that's the 50 centimeter cube, so it would be the same. Then d value is also the same, that's 85 multiplied by 8.33, that's the new volume that we are going to use the second case, plus the V equals, that's 50 centimeter cube, so that's 50, and the n value would be 3. So when we calculate using the calculator, you can just place all the values in the calculator. The result would be 0.029. So as in the first case, the value would be 0.000029 gram. That's the value you get after doing this calculation. So for n, as the way that I have mentioned in the previous case, that you have to multiply it with 1000, that would become 1 2 3, so it would become 0.029. And what we have to do, we have to subtract it from the 100. So 100 minus 0.029, that would become 99.97. So this is the short trick that is being used to calculate extraction efficiency, as we have to like subtract it from this one, and we have to calculate accordingly. So one of the simplest ways, just multiply it with 1000 and just subtract it from 100, you will get the extraction efficiency. So in this case, we are getting 99.97% extraction efficiency if we do the multiple extraction. In the previous case, the case one, where so I just mentioned case one, we will get 97.7% in the previous case, and in the case two, we're getting 99.97. So if we're doing multiple extraction, then that would be much more efficient because the extraction efficiency in multiple extraction is much more higher than in the normal case. So that's it for if we want to calculate extraction efficiency, you have to use this formula. Remember this one. And then we're going to cover the second part, the what's the effect of complex formation with the example of iodine. Thank you so much.